All right, so we have our second video for dividing rational expressions. I'm going to go ahead and zoom in on this first one. This problem looks like it's set up a little bit different. I'm going to go ahead and rewrite this so it looks like the other problems we've been doing. Our first fraction is y squared minus 5py plus 6p squared over y plus 2p. And then this big division, that's the divided by right here in the problem. And then y squared minus 4p squared. I'm going to go ahead and put that over 1 so that we have that fraction to flip. All right, so anytime there's a problem with addition or subtraction, you want to factor everything, then we will flip and multiply and see what cancels. So first thing I'm going to look at is this y squared minus 5py plus 6p squared. So we're going to multiply. Our first terms have to multiply to y squared, so we're just working on factoring this, so y times y. And our second terms have to multiply to 6p squared. All that means is that your number is going to get a p, and because this was just a y squared, we can do that shortcut factoring where we say what are factors of 6 that add up to negative 5. Because it's factors of a positive 6, I know both of our factors will be negative, so I'm going to go ahead and put minus signs. And then negative 2 times negative 3 is positive 6, and negative 2 times negative 3 is a negative 5. Or add those, I don't know what I just said. But anyway, that is factored. So I'm going to go ahead and rewrite the problem. So this turns into y minus 2p times y minus 3p over, now this is just two terms. Anytime it's two terms, you want to see if there's a difference of squares pattern or if they have a GCF. Because of the addition, I know it's not difference of squares. And then do they have anything in common? They do not. So that's just going to stay as y plus 2p. All right, then I go back to the problem and I see we have our division. Dividing by this fraction, we're going to change the division to multiplication, and we're going to flip this second fraction. So that 1 is going to go on the top, but that y squared minus 4p squared, so there's subtraction. We want to think difference of squares or GCF. So I'll go ahead and look at this up here. Y squared minus 4p squared. Anytime you have things that are squared with subtraction, you want to see if it's a difference of squares. Do we square anything to get that term? Do we square anything to get that term? So a y will work because y squared is y squared, and then a 2p will work because 2p squared gives you that 4p squared. So this is a difference of squares pattern. We're going to use the y and the 2p. We're going to have y plus 2p and then y minus 2p. All right, so everything is factored, and it's multiplication. So if you remember, I just like to make this one big multiplication. I'm going to go ahead and put parentheses around this y plus 2p because that gets multiplied by the other ones. And we are just looking for anything on the top that might cancel with anything on the bottom. So I can see we have a y minus 2p and a y minus 2p. And it doesn't really look like anything else is canceling. So our final answer on the top, we have a y minus 3p times that 1, which is just y minus 3p. In the denominator, we have a y plus 2p and another y plus 2p. So we'll go ahead and put those together and say it's a y plus 2p squared. Even though our answer doesn't look all that great, that is a simplified answer. All right, next example. Okay, so in this one, first of all, let's take care of this x plus 1 to the negative 1 power. Remember, if it's a negative 1 power, it's going to go to the bottom of your fraction. So this really will turn into 1 over x plus 1 to the positive 1 power, which is just x plus 1. Okay, so I'm going to ignore this. All right, we're going to rewrite this problem with everything factored. So this x squared minus 1, that's a difference of squares pattern. That will factor into x plus 1, x minus 1, over. Here's a basic trinomial, we're looking for factors of 4 that add up to -4. So that's going to be x minus 2, x minus 2. So even though it's 2x minus 2's, I don't want to put those together right now because I might cancel some of those out within the problem. All right, divided by this fraction. Remember, we're going to take that division, turn it into multiplication. That x minus 2 goes on top because we're flipping that fraction. And on the bottom, we're going to factor this. It's a basic trinomial. Do we have factors of 1 that add up to a -2? And in your head, you're saying, well, yeah, that's a -1 and a -1. All right, I'm going to go ahead and do this all at one time. This is being multiplied by our third fraction, so I'm just going to carry this down, 1 over x plus 1. All right, so now we have all multiplication straight across, so I'm going to make this one big fraction, because that's what would happen if we multiplied straight across. I'm going to go ahead and put parentheses around the x minus 2, and now I'm looking for anything on the top that might cancel with anything on the bottom. So first I see we have an x plus 1 and an x plus 1. Here's an x minus 2 canceling with an x minus 2. We've got an x minus 1 canceling out an x minus 1. And everything from the top is gone, so we're ready for our answer. All that we have left up top is a 1. And even if that 1 was not there, if everything cancels away, put a 1 in its spot, because you need something up top. And then on the bottom, we have an x minus 2 and an x minus 1. And that's going to be our final answer.